Welcome to this video. Today I'm going to be solving five or six questions that were actually on the August SAT. So you can see whether or not you got them right and you can see how they're done if you were confused on them. But yeah, these are real questions that I saw on my test. So yeah, let's get right into it. All right, let's get right into the first question. So it says a function h is defined by this, where b and c are constants, and then these points are on that line. And then it just says if h of m equals 0, what's the greatest possible value of m? Okay, let's define this function in desmos. So h of x equals negative square root of x squared plus bx plus c. And then it says we have these points on that line. So we'll define those with a desmos list. So we'll say h of, what was it, 2, 0? So h of 2 equals 0. And then h of 0, right, it was h of 0 equals negative square root 358. Negative square root 358. Okay. Sorry, that's supposed to be a comma. Okay, so as you can see, first of all, some weird values here, and our RMSE is high. So right off the bat, that's not good. And then what we can also see is our point 0, negative square root 358, is not on our line, so that's definitely a problem. So what we can notice is that when x is 0, y is negative root 358. So let's plug this in. So if y is negative root 358, then x is 0. So it would equal negative square root of 0 plus 0 plus c. In other words, negative square root of c equals negative square root of 358, so c equals 358. So that's a key detail we need to notice. And then let's double check our point. And then we can see it falls on the line, and we have much cleaner values. Our RMSE is 0. So now we can actually answer the question. So it says, if h of m equals 0, what's the greatest possible value of m? That just means what's the greatest possible x value where y is equal to 0. So that would be over here when x is 179. So 179 is our final answer. All right, next question. To hang a garland, someone is putting nails on a board that's 11x feet long. They put one nail on the left side. For every 11 over 12 feet, put a new nail, with one nail at the end on the right. Which is the correct equation to determine how many nails they use? Okay, so let's draw this out right here. So let's imagine they put one nail on the left, nail, 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 blah, 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 all the way until they put one final nail on the right. That's an important part. So they put one final on the right. So what we can do, we know this whole distance is 11x, and then they put one nail, so like, let's just say this distance is 11 over 12. So what we can do now is we can take our total distance, 11x, divide by a rate of change, 11 over 12, which is basically just saying 11x times 12 divided by 11. 11's canceled, so it's 12x. But now we have to remember they put one final nail on the right. So what you have to do is you have to plus 1 for that one final nail. So 12x plus 1 is going to be the equation to determine how many nails they used. So yeah, pretty simple question actually, and that's how you solve it. Okay, this one showed up right at the end of the test, so if you got this one, let me know in the comments, but let's get into it. So two data sets of 23 integers summarized in histograms. For each of the histograms, first interval represents the frequency of integers greater than or equal to 10, less than 20, and so on. So basically, in this column right here, if there were any values, they could be 10, but the biggest they could be is 19. So we'll keep that in mind. And they're asking for the smallest possible difference between the mean of A and the mean of B. So how you solve this is we have to find the greatest possible value for data set A and the lowest possible value for data set B. So what we can do is we can just go through each column here. So first one, there's 3 values, and since we're looking for the greatest, it has to be 29. So 3 29s, and then next there's 4 39s, and then there's 7 49s, and then there's 9 59s. Okay, now what we can see is we have to make this the smallest. So what we can do is we can see small, so we also can notice that there's 3 in the first. It goes 3, 4, 7, 9, and here it goes 3, 4, 7, 9. So we'll keep that in mind. 3, 4, 7, 9, and there's 3. We're trying to make the smallest, so it's 10. Oh my gosh. All right, this next question says, 2 data sets of 23 integers are each summarized in the histogram shown. For each of the histograms, the first interval represents a frequency of integers greater than or equal to 10, but less than 20, and so on. So basically, in this column right here, the integers can be as small as 20, but only as big as 29, and so on. So, and then they're asking for the smallest possible difference between the means. Okay, so to do this, we'll have to find the smallest in data set A, and then the biggest in data set B, so we can compare the smallest difference between means. So let's do this. So we can see in this column there's 3, the frequency is 3, and the value is going to be 20. The next one, there's 4, value is going to be 30, and then there's 7, value is going to be 40. Sorry about the handwriting. And then 9, value is going to be 50. And for this one, we'll find the biggest. So as we can see, it goes 3, 4, 7, 9 in this one, and it's the same in this one, 3, 4, 7, 9. So we'll put 3, 4, 7, 9. So we know the weight is the same, and that's an important part. So now that we know the weight is the same, we can just compare the values. So for this one, the biggest is going to be 19. And then for the 4 column, it's going to be 29. For the 7 column, it's going to be 39. And then for the 9 one, it's going to be 49. And since we know the weights are the same, they don't even matter. So now we can just compare the values. So 20, 19, 30, 29. What you might notice is that they're 1 apart. They're all 1 apart. So our answer is going to be the means are going to be 1 apart. That's the smallest it could be. So if you put that answer, congrats, you got that one right. And that's how you do it. All right, next one. A sphere with radius 5 is inscribed in a right circular cylinder such that the sphere is tangent to both circular bases and the curved surface of the cylinder. Total surface area in square units of the cylinder. Okay, let's draw this out. So let's draw the cylinder first. So got the circular bases and the height right here, and then we'll just draw the sphere. So it's tangent to these edges right here and the center of the circular bases. So let's just pretend that my oval here is a sphere, and then it has a radius 5. So this length is 5. Sorry, that's a bad 5, but that length is 5. So we know radius is 5. And what you can notice is that you can see the radius goes this way too. So this is also 5. And what you can see is that this length is the same as this length. In other words, the height of the cylinder. So we know the height of the cylinder is 10 now. So that was important. And then we can also see this is a radius too. So this is 5, and that matches up exactly with the radius of the circular base of the cylinder. So this is 5. Sorry if there's so many numbers here, but basically the radius of the circular base of the cylinder is the same as the radius of the sphere. So radius equals 5. And since we're finding the surface area in square units of the cylinder, and we have all these, we can find it. So the College Board does not give you the formula for a surface area of a cylinder, but we can totally just derive it ourselves. So first, we'll look at the circular base. So it's going to be pi r squared. Since there's 2 of them, we'll do 2 pi r squared plus the curved region. So the curved region is basically, if you unfolded the cylinder, it would basically just be a rectangle. And the height of the rectangle would be the height, so 10, and then the width would be the circumference of the circle, so 2 pi r. So we'll do 2 pi r times the height, and since we have radius and height, we can find this. Let's put this in the desmos. So 2 pi r squared plus 2 pi r height. Radius is 5, height is 10. So this is going to be our surface area, but as we can see, they're all in terms of pi, so we'll have to divide by pi. And we can see 150 pi is just going to be our final answer. So yeah, kind of a tricky question. If you draw it out, it's not too bad. Next, a transversal cuts 2 parallel lines. One angle made at the intersections is 3x minus 20. Which of the following cannot be the sum of these four angles? Okay, let's draw our parallel lines and our transversal. So let's pretend that 3x minus 20 is the acute. So 3x minus 20, and this is in degrees. They definitely had the degree symbol on the test, but something went wrong here. So just pretend there's degrees there. But what this means is the obtuse would be 180 minus the acute. So 180 minus 3x minus 20. In other words, the obtuse is 200 minus 3x. Okay, so now let's see which of the following cannot be the sum. So let's see what can be the sum, and then we can rule out those answers. So the sum can be four acute angles, which should be 12x minus 80. See if that's an answer. Yep, that's B. Okay, so we know it can't be B. And let's try for obtuse angles. So that'd be 800 minus 12x, and that's A right here. So you can rule that one out too. And you might notice C looks pretty simple. There's no x's, no anything. It's just 360. And what you can notice is that this acute plus this obtuse is 180. But that means this acute plus this obtuse is also 180. So this full circular angle right here is 360. So 1, 2, 3, 4 angles can add up to 360. So that's out. And finally, 6x minus 260. It's the only answer we have left, but we can still double check. So to get a positive 6x, we would need 3 positive 3x and 1 negative 3x. So let's do that. So it would be 9x minus 60 plus 200 minus 3x. So that would leave us with 6x plus 140. And as we can see, 6x plus 140 does not equal this, so D is our final answer. So yeah, kind of a tedious question, but it's simple if you break it down. And then on to our final question. I got a couple people saying that this was on the test, so I decided to go over it. But yeah, a box in the shape of a cube has its top taken off. The volume of the box is 216 cubic centimeters. What's the surface of the outer part of the box? Okay, so volume of a box is just going to be side length cubed. So what we can do is we can cube root 216 to find the side length. So let's cube root that. That equals 6. So the side length then equals 6. Let's draw this cube. So excuse my drawing skills, but let's just pretend that's a cube. So side length is 6. Oh, sorry, those are bad 6s. But yeah, that's all you need to know. And then we're looking for surface area of the cube. So surface area of a cube is usually 6 times the side length squared, because side length squared is just going to be the area of one square base. But and the 6 comes from the 6 sides of the cube. But since one of them is taken off, there's only 5 sides. So the new surface area will be 5 times the side length squared. Side length is 6, so 5 times 36, and that just equals 180. So 180 is going to be your final answer for this question. And yeah, that wraps it up. That's 6 questions actually. That's 6 questions through that were on the August SAT. So let me know in the comments how your test went, how you felt, if any of these showed up. And yeah, thank you for watching.